Hello, glad to have you back. It's time to level up our code. In this episode, we'll dive into functions and the assignment operator, and we'll use them to clean up our Monster Battle Simulator source code. Let's start with this part. Have you noticed that this code is taking up a huge chunk of our program? Instead of keeping all of this code inside our main function, let's move it into a function. So what exactly is a function? A function is simply a block of code that we can give a name and run whenever we need it. In my case, I created a function called showWelcomeScreen. showWelcomeScreen is what we call the function name. Just like variables, function names can't contain spaces. So writing something like showWelcomeScreen is not allowed. That's why we write it as showWelcomeScreen. I'm using what's called camel case, where the first word starts with a lowercase letter and each following word starts with a capital letter. Now what about this void on the left? Void is the function's return type. When we use void, we're telling C++ that this function does not return a value. Our showWelcomeScreen function only displays some text on the screen, so we don't need it to return anything. That's why we're using void here. Functions can return other types too, such as int, but we'll get into that later. Next, we have this parentheses. These are part of the function syntax, and they can also be used to accept parameters. Parameters allow us to pass information into a function. We'll talk about parameters later, so for now, we're going to leave the parentheses empty. And of course, we have our opening and closing curly braces. Everything inside these braces belongs to our function. So we'll put our welcome screen code inside here. Now we have created our function, but there's something important to understand. Creating a function doesn't automatically run it. We've only told C++ what this function should do. To actually run it, we need to call the function. Whenever C++ reaches this line, it will run our showWelcomeScreen function. It executes the code inside the function. Alright, let's test it and see if it works. It works. Now, out of curiosity, what if we need to show this welcome screen again? We can simply call the function again. And as you can see, the welcome screen printed twice. Okay, so much for that testing. We will just print it once for now. Okay, so this time, let's take a look at the assignment operator. But before that, let's remove this part. We don't need it anymore. We originally used it to check which monster the player selected, but we'll be doing that in a different way now. Let's create another function called identifySelectedMonster. This time, our function will receive an integer selected monster. We will use the same logic as before. But instead of printing the type of monster, this function will return it. Since we're returning a standard string, we will use a string as the return type. For each condition, we will return the corresponding monster type. And if none of the conditions match, we'll return an empty string. So what has changed? This function now returns a standard string, and inside this parentheses, we have an int selected monster. As I mentioned earlier, This is called a function parameter. A parameter is a variable that receives information passed into the function and can be used inside that function. Now let's use our new function. First, we'll create a standard string variable called monsterType. Then we'll use the equal sign called the assignment operator to initialize our variable with the value returned by this function. The value inside the parentheses selectedMonster is called an argument. So what happens here? First, identifySelectedMonster receives the value of selectedMonster. The function checks which monster was selected and returns a string. Then, the returned string is stored in our monsterType variable. There is one possibility we need to handle. The returned string might be blank or empty. We'll interpret an empty string as an invalid monster selection. So let's add an if statement to validate that player's choice. If the string is empty, we'll display an invalid input message and end the program. Alright, let's test this change real quick. First, let's select number 4. Great! It worked! Now let's try an invalid number. And there we go! This time the program displays invalid input and stops. Next, let's get the monster health. We'll create an integer variable called monsterHP. We will follow the same pattern as before. We'll call getMonsterHP and give selectedMonster as its argument. The function will return an integer and that returned value will be stored in monsterHP. Let's do the same thing for the monster's attack. As you can see, both functions have a red warning right now. That's because we haven't created them yet. Let's create getMonsterHP. This function will return an int because HP is a whole number. We'll also give it an integer parameter selectedMonster, just like our previous function. The logic is almost the same as before, but this time, instead of returning a string like dragon, we'll return the monster's HP. We can use the values from our welcome screen as a reference. And if none of the monster numbers match, the function will return 0. The same idea applies to getMonsterAttack. To save some time, we can copy getMonsterHP and change the function name and return values. This time, we'll return each monster's attack value instead. Now that all necessary monster information has been collected, we are ready to start the adventure. Before that, let's remove this line. We don't need it anymore because we will display all the monsters' information when the adventure begins. Let's create a new function called startAdventure. This function will need all the information we have collected so far: monster type, monster name, monster HP, and monster attack. We'll pass all values as arguments when we call the function. Now let's create the actual startAdventure function. We'll use the same values as parameters, but this time we also need to specify their types. We can put each parameter on separate line like this to make the function easier to read. Inside startAdventure, let's display our monster's details. We'll show the monster type, name, health, and attack. And let's add a message here. To make it feel like we have transitioned from the welcome screen into the actual adventure, let's clear the terminal screen first. Since we're using Windows, we can use Standard System CLS. You might remember that I sometimes manually type CLS into the terminal to clear the screen. This time, we are asking the program to do it for us. For now, we are adding code that handles Windows and other operating systems differently. You don't need to worry too much about this part yet. We will explain these preprocessor directives in a future episode. The important part is that CLS clears the screen on Windows, while clear is commonly used on Linux and Mac OS terminals. And let's add a small message here to indicate that our monster is walking. It is just a message for now, but later in the series, we will actually create and animate this part. Okay, let's verify everything. I'll select number 3 for this line. Then I'll name it Rimuru. Nice! As you can see, the program called startAdventure and displayed all the information about our monster. These values will become useful in later episodes. For now, we are simply displaying them. Let's also confirm that invalid input still works. Perfect! As you can see, the program doesn't continue when we enter an invalid selection. I'll fast forward while I verify the other monsters as well. Congratulations! We just learned how the functions can organize our code, receive information, and return values back to our program. And now, our Monster Battle Simulator has all the information it needs about our monster. In the next episode, we will actually have our monster start walking and begin creating the world of our Monster Battle Simulator. If you're enjoying the series, consider subscribing. See you in the next episode.